Hello everybody! Welcome back to this stream where we talk about Quilibrium, the news that's been in the past few days since we had our previous stream, and some developer details that are going to be pretty important as we're moving forward and upward. So, to get things started, as always, a disclaimer. The discussion today is not a solicitation for investment and is not financial advice. The Quill and corresponding wrapped Quill tokens discussed on this broadcast are utility tokens, and Quilibrium Inc. does not endorse or encourage engaging in speculation on the utility token of the network. All right, with that out of the way, let's talk about the thing we always talk about at the beginning, which is our mission. Our mission is to secure every bit of traffic on the internet, whether that is in service of the Quilibrium protocol network itself, in service of crypto protocols, or the broader web. To get that out of the way, we are going to be setting an agenda for today. It's going to be a little bit different because it's relatively short since the last time we did a stream. So to get things started, we're going to talk about some news, and then we'll dive into some development info about the S3 and KMS-compatible APIs, and more in the topic of like how to build against it, because if you've built against the S3 and KMS APIs, it's basically the same thing, just some subtle differences. So to start things off, let's go ahead and talk about some recent events in the news. Literally, the last Thursday broadcast, I was talking about the fact that Apple had decided to, or Apple has been basically fighting the UK with respect to the laws that they were putting in place, demanding that the UK government was demanding that Apple put a backdoor into their advanced data protection. And needless to say, the response from the security community at large has not been particularly happy about that news. But what made matters worse is what happened the past few days. Apple decided that instead of actually fighting this, instead of even potentially pulling themselves out of the UK, they basically capitulated. It's a complicated situation. It's not capitulation in the form of a backdoor, but they still gave the UK what they want by basically removing the need for one. And this is something pretty crucial to think about with respect to how Quilibrium operates. Quilibrium Inc., of course, is a company. They are based out of the United States, therefore we have to be compliant with US law. If we receive a request that is related to something that we are doing on behalf of a customer, we may have to comply. But how we comply is important, and how you set up things so that compliance itself works is also important. Apple is a centralized provider of services for their customers. Apple's iCloud service, all of this is basically within the cloud infrastructure that they have set up themselves. And because they've set it up themselves, they haven't done anything to actually basically prevent these kinds of things from occurring. So you have a situation where Apple is able to push updates to phones. They are able to override the settings that they have already put in place. They have basically full control to remove the privacy that they have been adding to their product. And they've now proven that if privacy as a product is butting heads with a government that refuses to allow that to happen, they will just simply remove that privacy. So instead, when you design a protocol that is supposed to replace the broader web and provide security at every single layer, you have to design it in such a way that you can't do that, that it is impossible to do that. And so when you think about other services out there that provide at least just like a minimal thing, like for example, Signal, their focus is strictly chat. We have Quorum that provides chat as well, but that is just one singular product. Quilibrium is providing a lot more. But when you focus on the angle of how Signal does it, they essentially set it up so that they have as minimal information as possible. Signal does require, or at least had required for a long time, phone numbers in order to create accounts. This setup was basically so that they could ensure that there was at least some reasonable control against spam. But that is literally the only information they have. They have no logging of their infrastructure. They have no metadata that they keep. Every single bit of communication that happens between its users of their product is strictly between those users. Signal will facilitate the delivery, but at the end of the day, they don't know who they delivered it to or what it actually was because of the nature of how the protocol, the Whisper protocol, actually works. And so very similarly, Quilibrium is designed with that same kind of notion, not just for chat. Chat obviously is one of the reasons that this existed in the first place, but additionally for computation itself, for storage. For everything we do, we try to minimize the nature of how, if Quilibrium Inc. were ever given a court order, how we could actually meaningfully fulfill it by basically making it impossible for us to do so. And this is very important to actually safeguarding privacy. It comes back to that whole idea of don't be evil versus can't be evil. And that's why we've designed things the way we've designed them. And so you're going to see a little bit of that demonstration today about where the line is and where it's important for you as a user of Quilibrium to appropriately make your risk assessments when you're activating certain services and interacting with those services. So that out of the way, there's some other events that have happened. And unfortunately, I think some of you out there have, because I know a few of you folks have actually talked to me about this on a personal level. You may have seen a very awful video on Twitter over the past few days involving meme coins. I'm not going to describe it in detail. Twitch very much does not like discussing this topic. So I won't say what was in the video, but if you've seen it, you know it. If you've heard about it, you know it. I will say that regardless, if anyone is struggling with depression, there are resources out there. Never give up hope. There are people out there who care. I have had friends in my life who have suffered from depression. I have had friends in my life who have unfortunately been in a similar situation. And just always reach out. There are people who care. The reason why I bring this up isn't just because this is important to just say, it's because of the circumstances that led to this. The rampant nihilism that has been happening in this industry. I've spoken out against this nihilism of meme coins and the toxicity of crypto Twitter many times. But more to it, the nature of how some of the leaders in this space, indeed leaders of the very protocols these meme coins are popular on, have been engaging with the broader community. Since this has happened, instead of reflecting on the values that they've been promoting or the second order consequences that come from them, or even taking ownership for the degree of damage they've done, they've been spending this entire weekend shitposting about the Bybit hack and how Ethereum could roll back their chain, snarkily noting that there's been precedent for it. And this hubris, this complete moral decay, is the reason why it's been so hard for crypto to gain a foothold. And it's one of the very things that has really just like ground my gears. It's made me have such a polarizing view in how I engage with the industry. Quilibrium's values, what we stand for, is to revive the cypherpunk ethos, to restore protection to the very foundations that so many have sought to attack. Crypto has the potential to be one of those foundations, but not like this. We have to be better. We have to do better. And part of that is not dumping gasoline on the dumpster fire that this nihilism has adopted. It's having a focus on builders, not value capture of a conflagration being masqueraded as a form of success, not being comparative to others and trying to say, well, this other network is doing X, why aren't we doing this? And we have to actually think about things from more first principles. We have to think about privacy, not public ledgers that let people engage in front running, on sovereignty and cooperation, not tearing down another protocol in some pursuit of it's not that I succeed, but every other network fails. We're different. And we have to reflect those values through everything we do. Yeah. Next up is the Bybit hack. I'm sure a lot of people have also heard about this. About $1.4 billion in cold storage for Bybit was compromised and stolen by North Korea through their Lazarus team. There were a few people that were asking how that relates to how Quilibrium can provide a greater degree of protection. And we're actually going to cover how a design can be done that uses our KMS service, for example, to better secure, or at least better increase the security posture of a team that is needing something a little bit more warm than cold storage, but with a greater degree of security. And so we'll dive into that in a sec. Last but not least, our first new hire starts on Monday. We're very excited to have another developer on our team, and we're looking forward to all that we're going to accomplish with more hands in the cookie jar. And then finally, Quorum Mobile. It's been mentioned in a few avenues, but since this is where a lot of news gets shared and recaps, Quorum Mobile, we have been in the process of getting our Apple developer account set up so that we can actually get the test flights going. Still waiting to hear back from them, but the last iteration of exchange with them looks like we're basically in the home stretch of getting that ready so that we can actually start publishing the test flights and getting people trying out the Quorum mobile app. So, all that out of the way, let's go ahead and do what we always do and dive straight into the nitty-gritty of designing applications under these two new services. So let me pop open this window over here. And there we go. Okay. So when we're talking about designing an application on Quilibrium, one of the things that we've been very opinionated about is how applications get built should be as similar to the way that applications have previously been built on other network or on other cloud service providers. So in other words, not having to think about things in this like deeply decentralized context and all the like consequences that come from an application design trying to compensate for those differences, but instead something that is so similar to what they do that it basically is almost no different. And so I'm going to demonstrate that a little bit today by talking about two of the things that people do in application design. And the first is going to be the nature of building a decentralized app on another network, for example, like Ethereum, and then how that actually plays out in centralized components, and then how Quilibrium can be used to replace those centralized components into a fully decentralized application design. So to start things off, let's talk about your basic, let's talk about one of the most popular decentralized apps. We'll look at let's look at Uniswap, for example. So Uniswap is basically comprised of a few small pieces. Uniswap is probably one of the nicer examples because almost all of it is happening on the given network that it resides in. But there's still one very important component to it, and it's actually been one of those things that's been subject to a lot of litigation, is the fact that there is a centralized front end, and there is a fee component of it, of course, that you can simply ignore if you're just using the back end over on the smart contract side. But generally, when you build a decentralized application, it ends up following this kind of pattern of having the front end being put on S3, GitHub Pages, just some kind of static file host. And then you have the actual smart contract. And then if there's any sort of things that have to happen that are basically leveraging on-chain data, what you end up doing is you'll have like some tertiary indexing service and then another backend service as well that is interacting with that indexer to perform some sort of operation. And of course, this particular smart contract host in this case is Ethereum, but it can really be any sort of chain. It doesn't really matter. It's just whatever is the substrate for decentralized applications to be hosted. So when we're looking at this particular structure, the difference in how you can actually take these centralized components and move them into the decentralized world is very easy with Quilibrium because the way we've exposed these services. We've created an S3 compatible API that enables you to interact with it no different than you're interacting with S3. There are some caveats, and that's what I was talking about earlier. So when you have an S3 bucket, generally you have one of two varieties. You have one that is either private, where all of the contents of that bucket, list operation, every operation you would perform on it is essentially based on authorized access only. When you have that, there is obviously an issue. You can't host a public website on it. So instead, you would, if you were doing a static site on S3, you would make a public bucket. Now, if it's a public bucket, you have an interesting problem for somebody who's trying to make this on, or to put this on a privacy-preserving service like on Quilibrium's Q console. And what that comes down to is, well, it's a public bucket. How do we expose that? So the S3 compatible API basically gives you an option. If you want to do a public bucket, You can, but you are explicitly giving Quilibrium Inc. the decryption key for that given set of items in the bucket. Because otherwise there's no way for a public API to surface this in an unauthenticated context. There is also other options. You have the ability to utilize the S3 API in a completely like privately hosted context. And the way that this basically works is as follows. So if you put a file into our S3 API, you are literally just like taking a random file, like let's say you created a bucket, and then you put the file, like the object, on that S3 bucket. What happens behind the scenes is that object is being broken down into its concrete metadata. Obviously, there's different attributes of a object in S3 parlance, and in order to maintain API compatibility, we have to represent all of it. So that comes down to things like the E tag, of course, but things like the actual object tags that you can put on it. I know not every S3 compatible API supports this. We do. And all of these things are different fragments of information that get turned into verifiably encrypted data. Now, we covered this in the previous broadcast about what verifiable encryption looks like and how that actually gets stored. But what I want to focus on is the underlying pieces that come out of it. So in this structure, you have the actual encrypted blob, and then you have the associated proof data that comes from it. Now, what we care about when we're providing a public bucket, you're basically creating all these encrypted blobs, and then you have the associated metadata names that come with it. So we basically have a particular set of vertices that we are looking for and assign, and we basically assign that such that we are providing that metadata and exposing it to the public API service. And so our public API service essentially, gives an endpoint similar to Amazon S3's various regions, but it's just a singular region. And that's essentially a proxy service that when you receive a request, you have cached metadata up front that denotes buckets, bucket names, file names, and other associated metadata that we would care about exposing. So like things like content type can be generated on the fly. And then from there, it goes to find that particular bucket, grabs that associated decryption key, and then proceeds to fetch the relevant encrypted blob, proceeds to decrypt that encrypted blob, and returns the restored result. If you would rather have a private bucket, like for whatever operations you are doing as a business, then you can use the private buckets and you don't need to utilize this proxy at all. This is just literally to expose a bucket for reasons that you would want to do so. So in that scenario, you could actually sidestep this entire thing. And what we have is basically a local API that a company can have running in their own infrastructure and it can actually even be embedded in an application. And what it does is it provides that surface area for your S3 SDK to interact with and integrate with. And it will do all the operations that public bucket proxy is doing, privately configured to you so that you are actually maintaining that strict like trust boundary where Quilibrium Inc. is not involved at all. We just simply made it easy for you to manage this. The other thing also is if you do want to have the public bucket, but you don't want the files to actually be public, you only want like the easy cached access identifiers for it. So you want the public URLs, but you want to use like signed URLs so that you can allow somebody who has that particular decryption key to access it. That's totally possible. And that is another way you can, again, augment your trust boundaries accordingly. And so what that essentially does for you is it gives you, well, basically an S3 API. So let's take a look at what that actually looks like. Okay. Cool. Just wanted to make sure that this is popped up properly. Let's get this increased in size. All right, so I have the local S3 API running, and if I were to interact with it, I've already set up an authentication key for it, so that that particular step of the process is pretty straightforward. You just simply configure that when you're interacting with the API. So I have it exposed currently through localhost 8080, and when I curl localhost, it does the list all my buckets and gives you the name of the account and the associated ID, which is the public key, and that tells you, whatever buckets you have. And you can see right now there are no buckets. So let me go ahead and use the API real quick to create a test bucket. You can see that I've run this before, and you're going to see me make the same mistake I made before. Great. There we go. So S3 MB S3 test bucket. If you want to use the raw S3 API, it's the S3 API command through the AWS CLI. But for the sake of demonstrating like even the easy use case, there we go. We have a test bucket. And when we curl it, we now have that test bucket listed with its creation date. And so the next thing you would do, of course, with a given test bucket, by default, it is a public bucket. So if you want to configure that accordingly, be sure to configure that. But when you have that bucket, you would then want to put something in it. I need to actually make a file first. So let me just do test file. And we will have that. And now you can use the S3 API to proceed to add that file to the test bucket. Okay, and so now we've copied that file. The next thing we can do is, of course, because this is creating public bucket entries on the local API, of course, you can now curl it and you get it. The other thing that you would want to potentially do is utilize the tagging feature. And I can never for the life of me remember that. So let me see where the, oh, this is for bucket creation, my bad. And this is literally what I mean when I say like you are interacting with it the exact same as the raw S3 API. We strive for as much compatibility as possible. There are some circumstances where you can't have that, but we try our best to actually have it. So this would be AWS S3 API, put bucket tagging, bucket test bucket, and then tagging tag set key foo value bar. Oh, right, I need to actually have the endpoint specified, of course. And there we go. Similarly, when you're actually fetching the bucket tagging, you would do the, or sorry, bucket tagging, you would do the corresponding get operation. And like I said, I can never remember these. I always have to end up looking them up myself because there's just so much. And of course, there you go, your tag set. And that's basically it. So structurally, like these items are encoded onto the hypergraph following the given structure that's defined given the RDF schema that was created to provide this S3 compatibility layer. This REST proxy is basically on the fly dispatching these requests to query the hypergraph if it's not cached already as a result, retrieve those objects, decrypt them, re-encode them as the given RDF target types, and translate them to the given JSON structures that they need to be represented as in order to appropriately return a response. That's basically it. So that's the S3 API, and this is one of the things we're going to be exposing through QConsole very shortly. I know some of you have already taken a look at the updated Quilibrium website, and I've already heard a lot of heavy contention about that, and I definitely appreciate the feedback, and we are going to revisit that redesign. We definitely missed the mark on that, and so we'll be moving to something that should be better, but alongside that, we'll also have the link to the Q console on the build tab at the top of the nav bar. So keep an eye out for that. That's where you'll be able to find it. And last but not least, let's go ahead and tackle the design situation of Bybit. So for those who have heard the news about Bybit but don't understand what happened, Bybit is an exchange that is based out of Dubai, I believe, and they were hacked for $1.4 billion worth of ETH, and it has since been split, laundered, etc. through so many different channels. Essentially, it has turned North Korea into the single largest holder of ETH, which is a really shitty situation to be in. And so let's talk about how that hack actually happened and how they could prevent this, and potentially how they could actually leverage something like Quilibrium in order to give a greater degree of defense in depth. So talking about how the hack happened first and foremost, if you're unfamiliar with how cold storage is supposed to work, the idea is at a high level you basically have what is called hot and cold separation of wallets, so that you have a way to securely manage funds such that your risk is significantly minimized in the event that you have some sort of internal compromise at your company. So an exchange, for example, would have significantly more assets in their cold storage than they would have in their hot storage. The hot storage is essentially intended to keep enough liquidity such that they are able to provide support for user withdrawals. And if they do any advanced chain integrations, being able to support those as well. But like largely, we're talking about withdrawals. And so in the withdrawal scenario, what happens is there is a certain amount of liquidity that needs to be maintained. And so when you have a lot of different crypto assets, generally you tend to keep kind of like a running average of what the withdrawal rate is, what the deposit rate is, such that you're able to manage the funds so that you kind of keep your hot wallets essentially balanced. So you want to maintain some sort of threshold, and that threshold is basically your tolerance of what you're willing to accept or at least insure against in the event of a hack. So for example, like I'm just spitballing numbers. This is probably not what they were actually setting. Whatever they had set is probably an agreement they have maintained with whoever does the insurance for their hot storage. Generally, exchanges will get insurance for hot storage and won't get insurance for cold storage because cold storage is intended to be, well, cold and untouchable and very safely guarded. So let's talk about what's supposed to happen with that. So the hot storage, let's say that they have a limit. Like they have an insurance limit. They will cover up to, like the insurance company will cover up to $10 million in the event of a hack. And they have some degree of like leeway that they're allowed to step over for wallet balances because simply movements happen so fast in this industry, and sometimes the values of these cryptocurrencies also fluctuate very sharply. And you need to smooth around that, or otherwise you're going to be constantly having to do movements. And so what tends to happen is you'll have a mix of assets. Like we'll say this is ETH, we'll say that this is Sol, we'll say that this is Bitcoin, and so on. And so you have your hot wallet storage set that you are maintaining some quantity of assets in your hot wallets. Okay, so when you have cold storage operations happening, generally they'll use some word for it. Like some will call it sweeps and restores, some will call it deposits and withdrawals, like they would with actual customer interactions with their hot storage. It just depends. It's whatever convention they use is going to be potentially unique to them, but for the sake of keeping things consistent for the language I'm going to be using here, we'll just call it sweeps and restores. So when you are sweeping something to cold storage, that's very simple. The hot storage has essentially these collection of keys. They live in some place that is connected to their services such that they can invoke an API call. It will construct a transaction and broadcast it on-chain to send that particular set of funds to cold storage. And what you end up doing typically as a custodian is you'll have a collection of cold storage addresses that are associated with the particular target assets that you're wanting to manage. How each company does it is a little bit different. Here's what Bybit basically did. They had a cold storage address, or at least they said it was a cold storage address, that had $1.4 billion worth of ETH-related assets. That's ETH and associated like staked ETH and so on. And so when you hit that limit here, what's supposed to happen is, like, say that it goes over the limit, it will initiate a sweep to cold storage. There's a given set of public addresses that are known in that for the cold storage wallet targets, and it will create that transaction and send the funds over. So far, so good. What's supposed to happen is when you hit essentially a low limit, so like you're getting too low on funds that exist inside your hot wallet, you initiate a restore operation. And so what's supposed to happen with a cold storage operation is you have people dedicated at the company who have, you know, gone through incredibly deep background checks. Their identities are typically not known because otherwise they'd be a target. And they will perform whatever operations are necessary to restore the cold storage funds such that it is sent over to the hot storage wallets. Here's a couple of things that I could immediately pick up from the details of what they were giving in the call about what they've been doing wrong. So, and keep in mind, I also previously worked at Coinbase where I was one of the people maintaining cold storage. I very intimately know how cold storage should be done. And so it was very quick attenuation from me to have my eyebrows perk up when I heard what they were doing. So here's what happened first, and the first thing that went wrong. When you look at the cold storage operations that they had, first and foremost, the wallet was not cold. Like, just flat out, the wallet was not cold. It was a smart contract wallet called Gnosis Safe. And don't get me wrong, Gnosis Safe is a great product, and used responsibly for managing smaller quantities of funds, it's perfectly reasonable to use. Like, your risk tolerance level for a hot wallet, for example, Gnosis would be great for that. But for cold storage, you're immediately having two conditions that should be never done in a cold storage scenario. The first is the keys that interact with it are repeated, like you keep using the same keys. So for example, these signers, the way they were using Gnosis Safe as cold storage is whenever they needed to do a restore operation, they were proposing a new transaction such that it would move funds from the cold storage wallet on Gnosis Safe to the hot storage wallets. And when they did that transaction proposal, then they would have their individual key holders that were holding, I believe they said it was ledgers. So those like hardware wallets that are kind of sketch. They were holding ledgers and would then do the signature for the multi-sig Gnosis Safe wallet, such that once the quorum of signatures was met, the transaction would be considered approved and it would meet the criteria for the smart contract wallet in order to move the funds from cold storage to hot storage. So that's problem number one. The key is constantly being reused for the same asset. One of the core principles of cold storage is that the moment that a key that manages funds is exposed in any way, whether it's a signature, whether it's actually like importing the private key and using it on a hot system, whatever operation you're doing, the moment you expose that key to the public internet in a non-air-gapped environment, you have made that key hot. And so when you are using Gnosis Safe to manage cold storage, you're effectively always dealing with hot keys. There is no cold key. And so that was problem number one. Problem number two, the nature of cold storage should be, in order to accommodate for that kind of degree of separation that should occur, should never have $1.4 billion in a single address. And so the way that proper cold storage should be done should be that you are actually splitting those funds out to reasonable bars. And what is reasonable is going to be contingent on the operations of your given exchange. but tends to be chunked into a given set of sizes. So like, let's say that you're, for example, like let's say that you are insured up to $10 million for a collection of addresses such that you have like maybe about $200 million in insurance coverage. You would want to basically be such that your addresses in cold storage are maximally, which of course values will fluctuate, so you have to accommodate for that, but essentially those cold storage addresses are bounded to a rough number. Like typically you will get like a weekly moving average of the price of an asset, and that will be how you set your boundaries over how many coins get deposited to a given address. But you will split it out into multiple addresses such that when you ever need to do a restore operation because you have gone underneath that boundary, you can safely take one of the cold storage keys that has been filled up and then make it hot, do the restore operation, and now your hot storage is funded back up to whatever acceptable bounds you have set. And it's basically that simple. So to do that, you have to actually have true cold storage operations. So let's revisit what they were trying to do. What they were trying to do is a very common way to de-risk the nature of having multiple addresses or having any address in cold storage and exposing it to the web. The moment you have an address that is exposed to the internet, you run the risk that there is some brilliant attacker out there that may take advantage of whatever vulnerabilities are available in order to redirect those funds. And so they try to have a defense in depth by using Gnosis Safe to manage these operations such that in order to compromise that interaction, it requires multiple signers of that wallet to actually agree to that transaction. Well, sure enough, that's exactly what happened. So the nature of the attack was each one of these signers for Bybit was actually given a forged interface. Basically, their machine was compromised such that the signature proposal they received looked like their typical cold storage restoration operations, but they weren't. They signed this operation essentially they were given a fake display that showed like it was just normal operations, but the actual thing that they signed was basically giving over control of the Gnosis Safe wallet such that the attacker could then drain all the funds. So that's basically like one of the common things that you design your cold storage around is such that that can't happen. And the way you do that is by having it as air-gapped as humanly possible. Like you're not going to have this like ability for things to gently interact on occasion. You don't have developers with their primary work laptops interacting with cold storage funds. Like that's just not how you do it. So instead what you do is you have basically a hard set of operations that are completely compartmentalized. So you create software that generates keys. Those keys that are generated using MPC processes that split them out into shards. One of the most common, in fact, practically the only way that people do it is called Shamir secret sharing. But there is actually a special variant that adds a greater degree of security, and it's something that Quilibrium uses outright for distributed key generation in the network, and that's called Feldman verifiable secret sharing. I've talked about it before in previous broadcasts, but basically it's that each party is running their own instance of the Shamir secret sharing, and then they're basically constructing samples of that polynomial for each participant. They add them together, they create their individual samplings, they emit their public points of those samplings with a zero knowledge proof attached to it to show that they did not cheat, and then also at the end everybody combines their public samplings such that you now have a verifiable result that this, like, every participant behaved honestly and every participant can reconstruct the same key, but none of them actually have the full private key. And so that's like some really fun mathematics that are great about MPC. Now, if you're wanting to do cold storage, you would not do this MPC on the internet. You would do this MPC potentially in a tent. So, like, for example, the way that Coinbase does it, and there's actually public articles about it, I'm not giving any secret details. We would actually set up Faraday tents out in San Francisco where we would actually have, like, you know, the completely shielded off from the world. You'd have laptops spun up that are fresh laptops that are procured from sources that, you know, should be reasonable that they can't be tampered with. We would load it with AC, it would run the key generation process, create the shards, and then we would actually print out those shards and store them basically in a physical vault. And then the actual like digital assets, like the laptops themselves, like the things that generate the digital assets, I should say, those laptops themselves are then shredded. Every single bit of this is completely asserted that it cannot leave the tent if it has touched key material except for the physical paper, because paper can't be hacked. And so that's basically the principle. So that is the degree of minimization that for a custodian that is managing billions of dollars of assets, that's what you should do. Now, to make this work in the Quilibrium context and where it actually matters, let's talk about the restoration process. So say that you have those pieces of paper stored in the vault, and maybe you have separated it out such that there's different vaults that hold all the shards for a greater degree of protection, so that if your vault was actually physically compromised, they would have to hit each vault in order to obtain those shards and reconstruct the cold keys and do the actual theft. In the Q context, that's actually a lot easier to do, because instead of having to manage the reconstruction of these shards by having like some sort of physical location where everybody brings those sheets of paper together or scans them, uploads them, whatever, instead of having to do that, you actually just utilize the key management service such that you are posting those individual shards to each other in a given ceremony. So the way that that operation works is that you have an import key step. So you will create these, I'll just use this to denote a split key. So you have your key splits. And then what is previously done in like the old school cold storage, you then have a step where these are basically uploaded and combined all in one step. So they get uploaded to like some private service that does the reconstruction, and then at the same time does whatever signature operation needs to happen. And maybe they'll use something like a TEE to give a chain of custody that the signature operation that is being performed is something that has been audited and signed off on, and you end up with a signature output that moves the key, and the key is now essentially considered dead because the funds have been transferred from it and the key splits are now useless. And so that's the old school output. You get a signature, and that's basically it. You broadcast it to a chain and you're done. So when you're wanting to move away from that into something that is a bit more resilient, because keep in mind that trusted execution environment, as an example, is something that can be compromised. TEEs have been hacked plenty of times. Private services have been exploited plenty of times. If every single thing you're trying to do with handling cold storage is to minimize your degree of weakest links, this is where you can actually get to using Q as a cold storage system, because instead of doing that, you now have a signature method that is actually performing a series of checks. And the way that you deploy applications to the network is something that essentially provides a deterministic check that cannot be violated. So like, I have created an application. It is essentially existing solely for the purpose of taking key shards and creating a transaction. That transaction is a transfer function of of ETH on the Ethereum mainnet. Here's all the details of it, and it resolves to a static hash that is unforgeable. So you can verify based on that information that those key shards are supposed to go there. But even better, you can actually make those in advance, such that when you are creating these key splits and you are storing any sort of associated metadata to be managed on cold storage when you use it on Q, you are doing so such that you are creating identifiers that are unforgeably bound to only do that one transfer function when the time comes. And so that basically sets the purpose of the key to something more specific than what Amazon KMS could even do, but also more secure than what even traditional cold storage that's very, very high security could be doing. and certainly way more secure than whatever the hell Bybit was doing with Gnosis Safe. So when you do that, you then upload those key shards individually to this transfer function. But remember, inputs on queue are private. So when you are doing this interaction, what's actually happening behind the scenes is you are constructing a garbled circuit and executing it such that each individual party is participating in this garbled circuit where those key values are being merged and a signature is being formed without ever revealing those private inputs to one another. And then you end up getting the output through the magic of MPC. You end up getting a signature output. Which means that the only place in time where key material is actually being exposed is now limited to individual locations that are intrinsically bound on purpose of what those keys can even do. That basically eliminates every single opportunity for an attacker to actually take advantage of these key splits. The only thing you would have to prevent is the secure restoration of those key splits and uploading and integrating with that particular cold storage signing process. That's way better of security than what is happening here. And so that's basically it. These are the things I wanted to run through tonight. I felt like these were important to talk about, especially because of all the news that's been ongoing. Next week, we're going to be going through a lot more news. I thought that some of this was going to happen this week, but some things take a little longer than expected, so we'll get to that when it happens, and I'll be excited to share it when I can. In the meantime, I will stick around for a few to see if anybody has any questions. Otherwise, we'll wrap it up and call it a night. Let's see. Hey, Phil. Let me see if, oh, there were questions. I'm sorry, I did not see this at all. These are on Twitter. What are size minimums or limits? Could it replace a SQLite DB? And I'll ask a clarifying question to that next question, but just one sec. So size minimums, there's not really a size minimum. Just understand that in terms of how, for the S3 service, in terms of intrinsic billing, the way that things work, we work in 54-byte boundaries. That's just the nature of how we're doing the verifiable encryption. So basically think of every 54 bytes as a billable chunk rounded up to 54 bytes. It's obviously not like 54 bytes is infinitesimal in terms of expense, but it's just something to keep in mind how the units of billing work. One thing to keep in mind about the S3 service and the minimums, maximums, etc. When we expose the the Q console and the associated API access for S3 and KMS, when we first expose it, we're going to be doing it such that we're handpicking a few folks who have been wanting to develop and use these services for a while. We vetted them. They're not going to just upload a bunch of like shit that is going to be a problem for us if they use the public buckets feature. So to start things off, in that limited beta, those folks will have a inherent limit up to 5 gigabytes that is like completely free. Basically a perfect parallel with Amazon Web Services limits. So you can upload up to 5 gigabytes of data, and then past that point, you have to pay for storage in terms of the costs related by Quill. So whatever the billing is for the Quill protocol is how much you would have to pay in Quill tokens or wrapped Quill tokens. We'll also have like USDC as an option for companies that do not want to have to deal with the conversion of assets. That's totally reasonable, totally fine. It's part of our business model to basically obviate over all of that if you don't want to deal with that. But for those who wish to use Quill, we're supporting both the Quill and wrapped Quill asset in order to utilize the S3 service. Next up, is it a bad situation to be in for North Korea or Bybit? So yeah, my question is, what do you mean by that? Like, is what a bad situation? I mean, obviously the hack's a bad situation, but I don't quite understand. While I wait for clarification, we have another question. Are we close to wrapping up M5? Yes. So milestone 5, I forgot to mention that. Thank you for asking. Milestone 5 has had basically three final objectives we got to get through. One is the hypergraph sync, or hypersync as we call it. There's been a few bugs. There is basically one final bug that remains that we want to get resolved before we get ready for the formal 2.1 release. That I'm gonna get tackled tonight, and once we're past that, then we'll basically have two items left to test for Milestone 5, which is testing QCL, that the token execution works as expected. That's the easy part, because QCL's been around for quite some time now. But and then after that, we'll be evaluating, shoot, I forget the item off the top of my head. What was it? Evaluating QCL, and then, shoot, there's one more thing, but sorry, it's not on my current stack at the moment because it's after the other thing, so I sometimes forget. But yeah, those three things are the things that need to be finalized, and then we move to 2.1, and that's literally all we have left. So we're very, very close. I have also observed that there are some others out there that are taking a bit longer than expected. I don't know if you, I don't know what their motivations are, but ours is to make sure that this is as bug-free a release as possible. That is strictly our focus, to ensure that 2.1 is a complete success in our launch, such that we don't have any showstoppers that lead to these long churns of having to do more and more releases in order to manage whatever pops up from it. We want to make sure this is as bug-free as possible. Yep, I still haven't heard the next step to that question. Let me refresh the page, see if it's not loading, perhaps. Oh, you were saying something like it was a bad situation to be in. Oh, okay. It was a joke question because it was like $1.4 billion. It's a bad situation to be in. Bad for whom? Well, definitely bad for Bybit. I don't know if it was bad for North Korea, but basically, where are they going to put the funds? Nobody's willing to accept it. So it's kind of like a burn event, basically. They just basically burned $1.4 billion worth of ETH effectively. Still not great. It's awful that happened, and obviously it comes down to the poor cold storage management processes I've previously was kind of grilling them over through this demonstration. But yeah, I guess that about wraps it up. So okay, when will the fundraising be finalized? Like I said, I will have news to share when I can share it. I had a feeling that news may have happened a little bit sooner, but sometimes these things are a little bit slower than you'd like. But I will share it as soon as I can. Cool. As always, you will be able to reach me on Twitter through direct messages. You'll be able to reach me on Farcaster. I'm at Cassie, and you'll be able to reach to me out on the community Discord channel as well. So if you are using any of those, you can find me there. And last but not least, if you're on Quorum, you can also find me there, and you will find me there most of all. So thank you all for watching, and I will catch you all next Sunday, hopefully with some really awesome news to give. All right, catch you later.